Director of Vishnu Dental College, Professor Dr. Suresh Sir, Principal, and Vice Principal, Professor Dr. Rama, and Organizing Committee, Head of the Department, Professor Dr. Ravikant Sir, and all other staffs, and my good senior, Shweta ma'am. Uh, I take this opportunity to thank everyone for giving me this opportunity. And before starting my presentation, I just want to submit my gratitude and respect to all the oral pathologists who has taught and inspired my teachers. And also I want to submit my respect and gratitude to my teachers who has inspired me to take up this subject. So today the topic is going to be hallmarks of oral cancer 2.0 and update. So being a undergraduate student or postgraduate student or an healthcare professional, it is essential to know what is cancer and what is the molecular biology going behind the cancer. So when a root canal case comes or some other implant case comes, we are readily accept because it is a money making procedures. But when it comes to cancer, it is a life-threatening procedure, or it's a life-threatening disease, and it is important to know what is going behind it. And I have prepared this slide to make it little more interesting because I'm always a slow learner and a backbencher. So I cannot understand the molecular biology when I read it first. So what I used to do, I always correlate the molecular biology event with a normal happening so that it will be easily understandable for me. So that's why I have prepared with some correlations where you can get some take-home message. And I'm sure UGs will at least understand what is cancer and what is going behind the cancer. And I have given some highlights for PGs, those who are appearing for the exam. And it is greetings from Vivekananda Dental College for Women, South Asia's first women's dental college. So to begin with, cancer is an end product of an untermed proliferation of cells resulting from the growth of unequal or sequential genetic alteration, that is mutation, in a precursor cells. One of the major public health problem faced by Indian subcontinent is oral cancer, and it ranks among the top 3 types of cancer in the country. These cancers are associated with the use of tobacco, betel nut, areca nut, smoking, and alcohol consumption. Along with that, even sharp tooth also plays one of the major role. According to the fact sheet released by the Indian government and WHO together, comparing with previous 2018 data, there is a huge increase in oral cancer, like cancer of lip and oral cavity, which we are, as a dentist or oral maxillofacial pathologist or oral medicine or oral maxillofacial surgeon, who are more specialized with. So when you take a cancer, it is not a single event, it is a multifactorial event, and it is a multi-step event. So it doesn't happen within an overnight procedure. So before going into the hallmark of cancer, that is what are all the events taking place in the cancer, I just want to highlight the normal things first, that is the cell cycle, which you would have all familiar with during your general pathology, second year general pathology. So what happens during a cell cycle? So the cell cycle during growth 0 phase, the cell goes for quiescence, and G1 phase is a growth 1 phase where the cell organelles like mitochondria duplicates and it gets doubled. And S phase, which is a synthetic phase where the DNA duplicates And G2 phase is the growth 2 phase, where the cell grows and prepares itself for the division, which is mitotic phase. And M phase, which is mitotic phase, where the cell will divide into two different cells. One is daughter cell and another one is mother cell. So here, to control any abnormal behavior of the cell, there are few checkpoints to screen the cells which passes from one phase to another phase. The first checkpoint will be at the end of G1 phase, and it will surveillance the cell whether it has any problem with the DNA and the cell itself. And there is another checkpoint at the end of G2 phase. It will always check the cell before it goes for mitotic division. And there is another checkpoint in M phase to check whether there is a proper division of the cells are happened. So as we all know, when it comes to a cycle, there has to be some driver for it. So here, this cell cycle is driven by cyclins and CDKs. So this cyclins and CDKs, they are considered as the drivers of cell cycle. So what this drivers does, they help in transport from one checkpoint to another checkpoint, or else from one phase to another phase. For example, cyclin D and CDK4 and 5 helps in the driving from G1 phase to S phase. And in the end of G1 phase, there is cyclin E and CDK2, that is cyclin dependent kinase 2. And at the S phase, there is cyclin A, and in G2 phase, there is cyclin B. So this cyclins and cyclin dependent kinases, they just act as the drivers of the cell cycle, which means if there is any reduction in cyclins or cyclin dependent kinase, which are proteins, there will be reduction in cell multiplication. There will be reduction in cell division. But what happens when there is an increase in the amount of these proteins, that is cyclin and cyclin dependent kinases, the cells goes for rapid proliferation. So that is the role of cyclins and cyclin dependent kinases. So there is a cycle and it is driven by cyclins and cyclin dependent kinases. And there are some checkpoints to monitor the cells which enters from one phase to another phase. If there is any abnormal mutation is seen, the cell will be sent for death, that is apoptosis. If it is fine, then it will be passed on to next phase. This is the physiological cell cycle. But what happens, there are two different genes which helps in this event, that is the passing on from one phase to another phase. So what happens when there is a carcinogen, whether it can be a chemical carcinogen or it can be a physical irritant, that is your sharp tooth, or if it can be alcohol, or it can be a spicy food, or it can be a sunlight, or it can be any thermal kind of carcinogens. What happens? There is a mutation in this kind of gene happens. So this mutation can be classified as point mutation, gene amplification, chromosomal rearrangement, and epigenetic modification, which is called as methylation. So to make it simple, there is two set of genes. I'm not going to in depth with all this molecular behaviors. So we will take these two genes, oncogenes and tumor suppressor genes. This oncogenes comprised of growth factors, intercellular signal transducers, transcription factors, cell cycle regulators, that is the cyclins, which we already saw, and the inhibition of pro-apoptosis signals, that is BCL2 and BCLX and even BAX. So this oncogenes, when it gets mutated, that is, this is the mutation here, when it gets mutated with any of the carcinogens, what happens? there will be a continuous proliferation. That means if a car goes here in a normal speed, then it is safe. But if it is accelerated with too much of speed, it is always an hazard to the drivers and in the environment. The second set of gene is tumor suppressor gene, which is we are familiar with P53 and retinoblastoma gene. So what is the role of this tumor suppressor gene? When this gene finds any abnormality in the cell, if it finds any genetic mutation, it asks the cells to go for apoptosis, that is programmed cell death. Or if it is repairable, it will repair the gene and it will bring back to normal. That means this tumor suppressor gene acts as a brakes. So one I told as accelerator, and another one I told it as brake. So if you imagine this picture as oncogenes and tumor suppressor gene, your oncogene will act as just your nitrous gas. I think you are familiar with Fast and Furious, and late Mr. Paul Walker is one of my favorite person in that movie. So in those movies, I think you would have seen that nitrous gas release will accelerate the car motion. So that is what the role of the oncogenes. If it gets mutated, then there is too much of proliferation events happening, because this oncogene activation results in transcription factors release, which helps in the continuous growth of the cell, continuous proliferation of the cell, and continuous cell survival. And in another hand, if you take tumor suppressor gene, that is P53 and retinoblastoma gene, which was supposed to be act as a brake, what happens? There is no brake because of the mutation. So here this tumor suppressor gene, it gets two hit, that is called as loss of heterozygosity. So now there is too much of fast acceleration is going on, and there is a loss of brake, which results in a severe damage, which is a cancer. And I'm sure everyone is waiting for March 25th for the release of RRR. And if you see here, this heroes, they have a perfect rhythm, and when they have to stop, they are stopping. So this is what happens in a physiological cell cycle. So when the cell has to proliferate, it proliferates. When the cell has to stop proliferate or division, it stops. But what happens when it comes to mutation? It just looks like our routine party dancing. So we don't know where to start, we don't know where to stop, we don't know what step to put, and both the allele, it goes for dancing in their own direction. So this is what happens when this oncogenes and tumor suppressor gene gets mutated. And I think you are familiar with our superstar Talevar Rajinikanth. So most of them, when we are doing schooling, when we are doing schooling, this will be like our picture. So this is a normal senescence cell that is in the G0 phase. So it doesn't have any role. It will simply sit, and whatever happens, it doesn't bother. But what happens, a cell which goes for a G1 phase, it goes for the next proliferation. But what happens, just like when our interns outlook, when a schoolboy comes to a college, and when during his completion, during his internship, the look totally differs. Like what happens when it gets mutated, so the behavior is totally different. So earlier, there are 6 hallmarks of cancer, which we are going to deal with today. So first one is self-sufficiency in growth signal. So what happens here, either if a cell has to grow or divide, it has to receive a signal either by itself, which is called as autocrine, or from outside source, that is paracrine effect. So it can be through either Graf junction, or it can be through a signaling mechanism, or it can be through bloodstream. So these are all the examples of the growth signals and growth signal receptors. So what happens, to make it simplify, you just think this, I think most of you would have seen a weight seeing machine, right, in a railway platform. So when I was a kid, whenever I used to travel in train, so I always ask for 1 rupee coin or 2 rupee coin from my parents, and to see, not to check the weights. It is obvious, since I'm a heavy built person, it is obvious my weight will be overweight. But I just want to see what is the sentence written on it, very good fortune comes out of it. So what happens when we go and we put the coin, either it says something good will happen today, on that same day we will be made to stand outside the department for not writing the assignment. So that is what it happens. Or else sometimes it will come like you will meet your soulmate. So that is the day we'll be sent to meet our head of the department or principal for not finishing our work, right? The record works or something. And what happens? So this is a cell signal. And what happens when a person stands on it? There will be a proliferation of cell or division of the cell happens. Once the signal stops, the proliferation or the cell division also stops. But what happens in cancer, as I mentioned, there is a self-sufficiency in growth signaling. So the physiological signal stops, but whereas due to the mutation of this oncogenes, what happens with the transcription factors, there is a continuous signal will be received in an autocrine fashion or paracrine fashion. So that is why the cell cycle starts producing a tumor cell without a control. So there will be a continuous proliferation of cells happening. And next one is insensitivity to growth signals. So we always have a control, right? When we are going outside in a traffic, there is a traffic police. When we are in the college, there are some rules are there. When we are at home, there are some rules are there. So what happens when we become insensitive to this growth inhibitory signals? We don't know where to stop. So that is what happening. So this retinoblastoma gene or P53 gene or P21 or P16, which we saw in as a tumor suppressor gene, so our cell cycle will become insensitivity for this growth inhibitory signal. So because of this, what happens? There is a stop signal. So there is a person who prevents from entering inside because already the hall is full. But what happens when it is a tumor cell? It doesn't bother about any inhibitory signals. It directly enters inside the cell cycle and it keeps on proliferating. So in other way, we will call it as thick skin, right? Fine. And third one is evading programmed cell death or evading apoptosis. So if there is any mutation, as I mentioned during the cell cycle, so the cell will pass through the checkpoints, and if there is any abnormality found, the cell will be sent for apoptosis, that is programmed cell death. But what happens here? Because again of this mutation of proto-oncogenes and tumor suppressor genes, so it becomes insensitivity. So in normal cell, the signal will be sent and the mutated cell will go for apoptosis. But in tumor, what happens? It protects itself from this kind of apoptosis signals, that is BCL2 or BAX signals, or else in other words, sometimes it became insensitivity to this, respond to this apoptotic signals. So this is what happens. So coming to the fourth hallmark, which is telomerase or immortality. So in every gene, if you see, so there will be a telomere attached in each gene, which encodes for 3-5-. So this is called as telomere. And PGs, you can make note of it. It's an important Viva question, Hayflick's limit. So any normal human cell can only replicate and divide 40 to 60 times before it stops at division. Why? Because For each division, this telomere length will get shortened, and when it finds the end of the DNA, that's it, it will stop the multiplication or it stops with division. But in cancer, what happens? There will be an enzyme called as telomerase. This telomerase will continuously supply to this telomere to maintain this length. That means for each division, rather than reducing the size, the length will be maintained. So, and the proliferation will keep on going. So for a pictorial representation, if it is a normal cell, the normal cell goes for, when it is for a first division, it will be very active. And if it is like 25th division, slowly the cells, few cells will go for senescence or apoptosis. It cannot grow more and it will go for apoptosis. And at the end of 40th to 60th lapse, they will totally faint and there won't be any proliferation through this kind of monoclone. But what happens in tumor, there is, because of this telomerase and telomere lengthening, so there will be a continuous running of this tumor cell. That means that cells will keep on proliferating and the cells will keep on dividing. And any cell which has to grow more than minus 1 mm, it needs a fresh blood vessel. So that is what in a tumor, what happens, the tumor growth signals will send signal to the tip cells. Tip cells are seen at the end of any blood channel. So what happens, the growth factors will send the signal which helps in a formation of a new blood vessels. So this is called as activators and angiogenic inhibitors. So for PGs, this angiogenic switch is happening during tumor angiogenesis. Coming to the physiologic angiogenesis, while wound healing, there is also a new fresh blood vessels are formed, that is neoangiogenesis is happening. But here what happens, this is due to abnormal signaling, that is mutated signaling. It will be sent to the tip cells and there is a continuous angiogenic proliferation which feeds the tumor, helps in the growth. So this is the physiologic. So the alignment is proper and it is based on the architecture of our organs. But what happens in tumor, it doesn't bother about any of the the plants. There will be leaky, so attachment. So wherever it finds gap, it will proliferate and new blood channel will be formed. So I think in irrespective of any cancer or Indian cinemas, when heroes are affected with cancer, this is the classical picture, will showing like they will cough and they will bleed spontaneously. So that is a classical sign of any cancer affected by Indian heroes, movie heroes. And next one is tissue invasion and metastasis. So what happens, this tumor associated macrophages, it directs the tumor cell into the blood vessels. So when there is a tumor mass, so this tumor associated macrophages will guide or it will direct the tumor cell to enter into the bloodstream or the lymphatic channel. By the same time, for PGs, there is a terminology called as vascular mimicry, which is in another term we can call it as transdifferentiation. What happens, this cancer stem cells, it comes and attaches with the endothelial cells, and this endothelial lining itself will become a cancer lining, so that it will be easy for the entry of the tumor cells. At the same time, I want to mention one more thing. So there is a step 0 in metastasis called as pre-metastatic nick formation. That means irrespective of the tumor size or irrespective of the tumor cell size, it is already predestined that this tumor has to deposit and start its secondary growth in this particular point. So it is the researchers are stating that it is genetically predetermined. So that is why it is called as step 0, which is pre-metastatic nick formation. And I think you are all familiar with seed soil theory. So the tumor cells also should be vigorous. At the same time, the mesenchymal cells also should be very much potential to receive the signal. So what happens here? So this is genetically modified, which helps in the invasion of the tumor cells from one place to other place. So what happens? There is a leaky blood vessels. It gets inside and it goes and deposits in the pre-metastatic nick formation. So when we were doing post-graduation, this 6 hallmarks were considered as the main hallmarks. But what happens? The science, since there is a growth in science, there is 2.0, which there is an addition of 4 more hallmarks happened. The first one is tumor inflammation, and other one is the metabolism, deregulating cellular metabolism, avoiding immune destruction, and genomic instability. So I think in this picture, you can able to see this acute inflammation doesn't make a big role in cancer promotion, but whereas a chronic inflammation, long-standing inflammation will result in cancer promotion or cancer initiation. So in a pictorial representation, when there is any bacteria or any virus or any pathogens, we keep it as like that, pathogens. So there is an acute inflammatory cells, it causes minimal damage to the surrounding. But in case of long-standing chronic inflammation, what happens? There is an excessive damage happens to the surrounding. But what happens to the tumor inflammation? It doesn't know where to fight with. So because of that, what happens? It creates the environment where the tumor cells can form and the tumor cells can get initiated and promoted, and finally they couldn't able to recognize the tumor cell. So we will exactly come to our day-to-day life, like chronic inflammation induced oral squamous cell carcinoma or any malignancy. So there are studies stating that without any habits, that is alcohol consumption or without any tobacco habits, there are higher rate of increase in oral squamous cell carcinoma prevalence, especially in young individuals, those who have a chronic mechanical irritation. This was one such study we submitted to ICMR and which got accepted and published. So what we did, we just did a study, that is a breast biopsy or cytology study in a patient, those who are having sharp tooth and the patient without having sharp tooth. To our surprise, we found out there is an increased micronuclei seen in a patient associated with the sharp tooth. So this person, Dr. Jerome from Argentina, they communicated with us. We had a very promotive kind of communication, and they are pioneers in finding the link between the chronic mechanical irritation and oral cancer. So this chronic mechanical irritation, what it does, it increases the growth factors and helps in the sustained cell proliferation, which is the first hallmark, and it prevents the apoptosis, which helps in the third hallmark, and it helps in the genomic instability, which is the last hallmark. So this chronic inflammation, it has a role in all these 3 hallmarks of cancer. I think PGs, you can take a screenshot of it. This is the possible link between chronic inflammation and the tumor initiation and promotion. So coming to the 8th hallmark, which is reprogramming of energy metabolism. So normally our body, when we consume food, 3 cycles happening. One is glycolysis, another one is Krebs cycle, and third one is oxidative phosphorylation. So this by these 3 mechanism, what happens? The cell will produce energy, which is ATP. If this food goes through glycolysis, only 2 molecules of ATP is produced. After that, when it passed through Krebs and oxidative phosphorylation, there will be formation of 36 molecules of ATP, which our body requires for our day-to-day life. But what happens in Warburg effect, only this glycolysis happens, and this there will be a stoppage of this Krebs cycle and oxidative phosphorylation. And what happens because of that, there will be an aerobic glycolysis. And the researcher says only because of this, this tumor cell will escape from the inflammatory mechanism. So this is the physiologic process. When you take glucose or sugar, so there will be two ATPs, and this will be taken to the Krebs cycle as nicotinamide adenine dinucleotide and flavin adenine dinucleotide. So after passing through a Krebs cycle, it will pass through the oxidative phosphorylation, which will result in 32 ATP, which gives an energy to our body. But what happens in cancer patient? So they will feel very weak because this too, Krebs cycle and oxidative phosphorylation, it stops. The body will try to take all the sugars and try to convert it as ATP, which is an aerobic glycolysis. And the ninth hallmark is genomic instability. So what happens when you take a family, when a husband and wife is there, when they have mutual thoughts, like if you take Shweta ma'am and Ramesh sir, so if they want to construct a new house, so they sit together, they plan accordingly, and from them a beautiful structure comes, right? They make it as a home, not house. So when a homogeneous thought comes, so the end product is always a pleasing one. But what happens in a tumor cell? So this allele gene, each will go according to its signal. So they don't come and sit together and communicate among themselves. They don't have an homogeneous or harmonious relationship. So because of that, what happens? The structure which comes out of it is absolutely rubbish. So this is what happens in genomic instability. And finally, the end product will result in destruction. And the last thing is evading immune destruction. I'm sure Soumya ma'am will give a brief idea on evading immune destruction. But to simplify, what happens? So this our body immune cells will act as a barrier to prevent of entry of this tumor cells. But what happens when the tumor cells are more? They destruct this the immune cells, and what happens? It will enter into that area and starts proliferating and become a tumor, finally a destruction. So till date, this 10 hallmarks are considered as an classic hallmarks for cancer growth. But what happens, as I told, sciences keep on evolving. There is an upcoming new movie called as 3.0, where Talaivar comes as a miniature version. So here, there is a proposal for addition of 4 more hallmarks. So that is why I insist interns, those who are willing to take up oral pathology, which is a beautiful subject, kindly do at the earliest. If you wait and take for after 3 or 4 years, then there will be around 15 or 20 hallmarks that will become a burden for your study, right? So what happens, just to briefly go through it, there is the 11th hallmark, unlocking phenotypic plasticity. So researchers says it is not an actual hallmark, as I told during the angiogenesis. I think you'll remember the term transdifferentiation. This tumor cell will come and attaches with the vessel wall and become cancer stem cells. That is mimicry. So this is what happens in the 11th hallmark. The another hallmark is non-mutational epigenetic reprogramming. So without any mutation, because of this environment, there is an uncontrolled proliferation is going on. So they want to add it as an 12th hallmark as non-mutational epigenetic reprogramming. And as we all know, this oncoviruses, right? So they want to separately deal it as 13th hallmark, that is polymorphic microbes, which this act as it initiates growth, inflammation, immune invasion, all other hallmarks. So for one classic example is your Helicobacterium pylori, H. pylori, which induces the gastric cancer, which is again a microbe-induced cancer, and hepatitis, which induces our liver cancer, hepatocellular carcinoma. So that can be accommodated. And the last is the senescent cell. So it is like a tumor dormancy. Rather than it goes for tumor dormancy, it gets activated and gets aggressive. And I hand over the session to Soumya ma'am. I think she'll deal better with immunosurveillance. These are my reference, and I think I have, to the best of my knowledge, I tried to break this complex events into a simpler event. And once again, I thank the organizers for this wonderful opportunity, especially HOD sir, Ravikant sir is very much kind enough to give a platform to a juniors like me. So it's very kind of you, sir. My heartfelt thanks to you, and my sincere thanks to all my teachers, my gurus. So only because of them, I'm today what I am. So I owe all my success to my teachers and my seniors, Soumya ma'am, and my senior Sweta ma'am. They are always been a pillar of support. Sweta ma'am is constantly motivating me, encouraging me, supporting me. Ramesh sir and Sweta ma'am, from my college days, they are loving and lovely couple. So if I always cherish the moment we enjoyed in the conferences. Not only the conferences, we never missed to have fun during our post-graduation days, and it's an absolute honor. And I thank my wife, who is also an oral pathologist. I think you understand, if one home consists of two oral pathologists, how it will be. And but before my marriage itself, we took a strong oath that no discussion of oral pathology in home. And she's been a constant pillar of support. And my advanced oral pathologist day wishes. And thank you, Vishnu Dental College, for this wonderful opportunity. I stop this here. Am I audible? I hope my lecture was not a boring one. I tried to make itself short and informative.
Sir, can you hear me now, sir?
Yes, ma'am, absolutely. I can hear you.
Sir, that's so fascinating, sir, and also enlightening. It was very easily understandable even to undergraduate students, sir.
Thank
you.
It
was very pleasure to hear you and such a insightful presentation. Thank you so much, sir.
The pleasure is all mine, ma'am. Thank you.
Sir, there are few questions.
Yes. I would like.
So there are few questions in chat box. So can I ask you, sir?
Yes. We can go ahead.
Yes, sir. What is the role of vascular endothelial growth factor in tumor angiogenesis? That was the first question, sir.
Yeah. Okay. So, as I mentioned, which is the fourth hallmark, that is sustained angiogenesis. So there is not a separate growth factor for this tumor. This vascular endothelial growth factor is a common growth factor for any angiogenic event. If it is an embryology is concerned, or if it is a wound healing is concerned, or even if it comes to tumor. So based on this growth factor, that is the signaling alone, there will be a formation of tumor angiogenesis. So this vascular endothelial factors, when comes and attaches with the vascular endothelial growth factor receptor, then the signal gets activated, the ligand is formed, and there will be a formation of new blood vessels. I have pointed like the corner cells, the end cells in the tumor blood vessels. So when it receives the signal, it proliferates for a formation of new blood vessels. But recently, if I'm not wrong, the director from Chicago University, Mark W. Linden, is exclusively working on this tumor angiogenesis, where this VEGF and CD34 expression in varus squamous cell carcinoma or malignancy, the studies on VEGF and CD34 in malignancy, it is getting outdated one, because it started 2-3 decades back. And now, if they are mentioning, if it is a tumor angiogenesis, you have to go for a marker called as NOD1. So that is an exact marker for tumor angiogenesis. Otherwise, when it is tumor angiogenesis is concerned, VEGF is just acts as a growth signal, which is activated by the first hallmark, either through autocrine or paracrine, that is self-sufficiency in growth signal. I think I made it clear.
Yes, sir, it was clear, sir. Thank you, sir. There was another question, sir. How apoptotic markers, inflammatory and immune markers used as prognostic markers?
Apoptosis?
Apoptotic markers, inflammatory and immune markers used as prognostic markers.
Yeah, so when it comes to apoptotic markers like BCL2 and Bax genes, if you take, so as I already mentioned, this, if there is more expression of this BCL2, that is modified or mutated BCL2, it shows the cells keeps on proliferating. So when there is increased BCL2, it shows that the cell goes for proliferation rather than apoptosis. So it is one of the important biomarker, which can be added for any tumor prognosis measurement. And when it comes to immune related things, and I'm sorry, I'm not having that much knowledge on this immune destruction or the immune surveillance part. I think I can take the help of Soumya ma'am after her presentation.
Yes, sir. Thank you so much, sir. I hope very clear. Sir, sir, we congratulate you for the wonderful presentation and has been awarded with an appreciation certificate, sir.
Thank you, ma'am. It's my honor. And once again, I thank the management and team oral pathology for the opportunity.
So thank you so much, sir.
Thank you.
Thank you, sir. So the next presentation is by Dr. Soumya Makala, and the moderator is Dr. Smita from the Department of Oral Pathology.
Hello, good morning. Am I audible? Hello, good morning. Soumya ma'am? Can you hear me, ma'am? Soumya ma'am.
Soumya called me. Hello, Soumya. Soumya can't unmute and talk. Sir, no, you put your Soumya.
Yes. Okay. Hello, good morning, ma'am. You are nice to see you once again, ma'am.
Thank you, Smita.
Once again, a very warm good morning to everyone. Let me take the privilege of introducing my beloved teacher, Dr. Soumya Makarla ma'am, who is currently working as reader in Department of Oral Pathology and Microbiology in Krishnadevaraya College of Dental Sciences, Bangalore. Madam has pursued her BDS in BS Dental College and Hospital, Bangalore, and MDS from Annamalai University, Chidambaram. With her 12 years of experience in the field of oral pathology, ma'am has many national and international publications to her credit, which is among 51. And she has given many guest talks at many national and international forums. Also, ma'am is one of the enthusiastic co-editor for many prestigious journals like JMFP and Indian Association of Oral and Maxillofacial Pathology. Her curiosity never ends in learning, and she has many short-term training programs in AIMS, New Delhi, and in the Department of Plant Physiology, Bangalore, and in nanotechnology, IISc, that is again in Bangalore. So here we welcome you, ma'am, and the platform is all yours for the topic human cells and cancer, warriors or traitors. I'm handing over this virtual platform to you, ma'am. You can share your screen. Ma'am, you are not audible.
Thank you for that very nice introduction, Smita. It's actually a pleasure to have you to introduce me. She was one of our first PGs of our department in Krishnadevaraya Dental College. So it's, and thank you very much for having me to speak in this forum.
Pleasure is mine, ma'am.
I hope my screen is now visible.
Yes, ma'am.
Okay. So very good morning to everybody. And it is a great pleasure to accept this talk. And thank you very much, Dr. Ravikant sir, Dr. Shweta, Shivishi being my junior, Yoita being my junior. Actually, it's an amazing feeling to be talking amongst such an audience. And sorry. Thank you for providing this opportunity so that we can share some of the ideas on this platform. So greetings from Krishnadevaraya College of Dental Sciences and from the Department of Oral and Maxillofacial Pathology. Wishing all of you a very, very wonderful oral pathology day. Actually, it's a oral pathology week. Everybody all across the country are celebrating this whole week in honor of Dr. H.M. Dholakia, sir. So without further ado, I would like to start off the presentation because Dr. Yoitab gave us a wonderful introduction, and he spoke and he had a very insightful lecture into the hallmarks of cancer being version 1, version 2, and he also has introduced us to version 3, to which we have to look forward to and probably plan to work in these new frontiers. So moving on to immune cells and cancer. Really, are they the warriors of our immune system, or can they turn traitor? As Yoitab elucidated very well, this is the hallmarks of cancers version 2, in which, so we have to take cognizance of not only the classical hallmarks, but we also need to take cognizance of the newer hallmarks, which are probably now we have to call it as present hallmarks, and then we also have a future, like he said. So of these, now what the tumor cell is doing is that it is creating a conducive environment for itself to proliferate, and so that its survival and its immortality is ensured. So one of those methods, it has multitude of methods to do so. And one of those methods is avoiding immune destruction. So we have to know that the tumor is not just a proliferating mass of cells which can, induce its own vasculature, but there is always the role of a tumor microenvironment. So there is a crosstalk between mesenchymal cells, between the extracellular matrix, between the immune cells. So it's in constant crosstalk, or it's a complex interaction between the tumor cells and the tumor microenvironment. So of these, the immune system comprises of the innate and the adaptive immune cells. The innate immunity has so many cells, which I'll come to you in the next slide, whereas the adaptive immunity mostly comprises of the B and the T cells, which further can be divided into the CD4 and the CD8 T cells. So these innate immune cells, so what do? They comprise of all the granulocytes, the mast cells, the macrophages. What are these? These are the first line of defense. They are actually the foot soldiers. They do not hesitate to fight at the first instance, right? So they're always ready to pick up a fight with the intruding organisms or cells, and then they are not at all scared of putting their lives for this cause. But the time response for these cells is short-lived. The same thing when it comes to an adaptive immunity. It is then divided into humoral and cell-mediated immunity. Now these cells, they require activator molecules to get activated. So it requires an antigen presenting cell to recognize the antigens on the tumor cell and then present it to a T cell to activate it into either a cytotoxic T cell or a memory cell. So it just like, the line of defense, like a cavalry who's so brave and they just set out and go into the battlefield and they cause long-lasting damage. Now, the cells of the cell-mediated immunity comprise of T lymphocytes. So this T lymphocyte is a primary killing cell. It's also called a cytotoxic T cell, wherein when a tumor antigen is produced, the dendritic cell or an antigen presenting cell, it binds to the major histocompatibility complex and then presents the cell along with co-stimulatory molecules to the lymphocyte. Once the T cell gets activated, it then causes lysis of the tumor cell. So here we have to know one small thing, where all the nucleated cells in our body, they express this molecule, which is the human leukocyte antigen or the MHC molecule on their cells, which are detectable by these immune cells. And all the immune cells in our body, they exhibit MHC class 2 molecules on their cell surface. So going on to natural killer cells. These are basically the first level of defense or immune surveillance. So what are these cells? They act very quickly. They have a ability to kill on sight. Okay. So the speciality of these cells is that they target those intruding cells which do not express the MHC class 1 molecule. So the moment they see such abnormal cells, they go and attack and kill the cells. So they use two things, which are perforins and granzymes, which will induce killing of the cancer or the intruder cell. Now, macrophages and dendritic cells. So these are antigen presenting cells primarily, but they also have other functions like they can release lysosomal enzymes and reactive oxygen or nitrogen intermediates. So which will all these induce the killing of the tumor cells. Also, they play a role in antibody dependent cellular toxicity. And when it comes to dendritic cells, like you've already seen, they have a very important role to induce T cell activity. On the same lines, humoral immunity basically comprises of B cells and plasma cells. So these are the guys who produce antibodies. So when they produce these antibodies, they selectively go and bind to the targets on the tumor cell surfaces, and they induce lysis of the cell by pushing the cell into apoptosis. So what is the basic function of these cells is that all these white blood cells, the leukocytes, the immune cells of our body, what do? Their work is basically to patrol, just like a sentry patrols every day, everywhere, and to look for cells which express abnormal antigens. So the moment they identify such a cell, then the innate immune cells and the adaptive immune cells, they come into action and they go about in eliminating these cells. Now these cells, how are they recognized? The tumor cells, they produce or express a tumor antigen on their cell surface. These antigens can be either peptides or proteins, and they act as an indicator for the cell, the immune cell, to identify them. It is saying that, okay, I'm here, I'm here. It's like raising their hands. And it becomes very easy for the circulating immune cells to go and bind to these antigens and make a complex. So these antigens can be of many types. One is when a specific antigen is produced only by that particular tumor. They are called as tumor-specific antigens. There can be other aberrantly or overexpressed antigens by other cells. So they are called as tumor-associated antigens. These can also be produced in smaller quantities in normal cells. Other than that, mutated gene products can be expressed on the cell surface, which also act as antigens. And also those produced by embryonic and based like carcinoembryogenic antigen or oncofetal protein. So these are all antigens which are produced by cells which have gone back to the embryonic stage, as in de-differentiated. Apart from this, virally induced oncogenes can also be identified as tumor antigens. So now if you see, all these antigens are again identified by the production or the expression of an MHC class 1 molecule. So this, when it gets activated, it produces an anti-tumor effector mechanism. So the cells, again, is just a recap of what we did. So the cells most commonly responsible are the cytotoxic T cells, the new natural killer cells, the dendritic and the macrophages, and the humoral mechanisms. Now, all these put together comprise the host immune response. Okay, so this host immune response is what gave rise to the theory called as immunosurveillance or cancer immunosurveillance. So this was given by Paul Ehrlich in the 1900s, and Thomas and Bentham in the 1950s. They also modified this theory. So basically, what does this theory say? It says that the immune cells, they circulate throughout the body. They act as sentinels, and as they circulate and they find some tumor antigens which are abnormal or some abnormally transformed cells, they catch them, they recognize them and eliminate it using their own individual methods. Okay, so like you can see here in this picture, there is a tumor. It is presented in the antigens are expressed, and it is presented it to the T cells, which goes on to eliminate the cell. So if such a foolproof method is in place, then why do we still get cancers? So each and every cell in our body is already being patrolled by a set of soldiers, the immune cells. They already are having good mechanisms to eliminate these transformed cells. Then why do we still get cancers? So now extensive research has given an idea that the tumor and the immune system interaction is not one direction. It is a dynamic system which has given rise to the concept of cancer immunoediting. Now this comprises of three phases, that is elimination, equilibrium, and escape. This. Once the transformed cells are seen or identified by the immune cells, so what do? They launch a very rigorous anti-tumor response against these transformed cells. So they, by the production of interferon gamma, then certain chemokines, certain cytokines, and also by induction of more and more immune cells into the area of assault, they make sure that all these transformed cells are then pushed into the apoptotic pathway. The apoptotic pathway was very nicely explained by Dr. Yoitab, so I'm not going to detail about that. So this is an ideal situation. So all the cells are highly immunogenic transformed cells. Okay, so here you can see exactly how the T cells are attacking the cancer cell. So now there is a small population of these cells which do not undergo elimination. So they proceed to the next stage called as equilibrium stage. So in this, what happens? Again, there is interferon gamma, and the lymphocytes which are present, they do not allow these cells to proliferate, especially if they are harboring genetic mutations. Now, this is a very long phase. Okay, so once it stays in equilibrium phase, what happens? It next goes into something called as an escape phase. In escape phase, all the cells which have entered this escape phase are the ones which are non-immunogenic or very poorly immunogenic. So that means they do not respond to any immunogenic attack or assault by the immune system. So basically, they have masked themselves off from any kind of identification, and in such a scenario, they can proliferate to a very high extent, like uncontrolled growth, and cause the tumor to progress into a very large size and also infiltrate into its surrounding tissues. So now the focus shifts from the immune cell onto this very clever cancer cell. So what this does is it has devised thousands of mechanisms through which it becomes invisible. Okay, so it has devised physical barriers, chemical barriers through which it has made an environment conducive for its growth, multiplication, survival. Right? So when it comes to physical barriers, it has induced desmoplasia, a very abnormal vasculature system. It has induced a dense extracellular matrix, and it also has induced the proliferation of cancer-associated fibroblasts. Other than this, it also has harbored mutation upon mutation. So multiple mutations. What does it do? It becomes a genetic signature which is not identified, or it's not responsive to any kind of stimulus or any kind of treatment that is given to this cell. So apart from this, it also immunomodulates the immune response, and it creates an immunosuppressive environment in which it can thrive. So what are the reasons for evading or eradicating this immune response? So how all has it gone about doing this? So what happens is the tumors, they stop their production of antigens on their cell surface. They can also induce loss of MHC molecules. It inhibits the T cell, which inhibits the T cell activation. They can secrete immunosuppressive factors, especially like IL-10 and TGF-beta, and also cause the lack of co-stimulatory molecules on the cell surface, which again interferes with T cell activation. They can induce a new subset of T cells called as regulatory cells. So how exactly do they do this? So this loss of tumor antigens, wherein you find that the antigenic production is modulated by the tumor cell itself, and the epitope gets lost. The tumor cell thus becomes invisible. So suppose you don't see, you cannot identify the antigen, then where is the question that of any tumor cell and immune cell reaction? So there is nothing that is happening. So it evades any kind of interaction. Insufficiency of tumor recognition cells and molecules. So here what it does is slowly the amount of MHC molecules that are exhibited on the cell surface are slowly reduced, and finally there's complete loss of these MHC molecules, which allows for its free movement without getting any identified by the tumor immune cells. So here what it does, it itself produces some cytokines, agreed. Here it also induces its other cells like tumor associated macrophages and myeloid derived suppressor cells. So it induces these kind of cells also to produce certain cytokines which have an immunoinhibitory effect on all the immune cells which are circulating in that area. So it probably the immune cells might be getting frustrated. It's like they can smell that there is something fishy going on here, but they cannot see. So if they cannot see, they cannot have any kind of effect, or they cannot launch a counter effect against these tumor cells. Now here, like for the activation of this T cell, we require the binding of the antigen to the T cell receptor, along with the co-stimulatory molecules, which like CD28, which have to be bound to the dendritic cell. But if there is inhibition of these co-stimulatory molecules, then you can see that there is no activation at all of this T cell. Apart from this, they also induce dysfunctional dendritic cells, which play with the antigen presenting machinery. So the tumor cells here, they secrete certain cytokines again, which cause or which inhibit a dendritic cell to become a mature dendritic cell. So it remains as an immature dendritic cell, and it further causes suppression of T cell activation and suppression of T cell proliferation also. So it produces further cytokines, and wherein it will reduce the immune function of the overall microenvironment. This new, it also can become a tolerogenic cell. So what does this mean? That means it becomes tolerant to the tumor cells which are in and around these cells. So that means it's like live and let live policy. Otherwise, before that, all these cells had shoot and kill policy. So it's the immune system or the immune regulation is slowly turning towards the signals of the tumor cells themselves. Now, what are these Tregs? So they are a small subset of CD4 positive cells who also display CD25 positivity and FOXP3 positivity. So the moment these cells are induced by the tumor cells themselves, and also they have MDSC cells which have an effect on their proliferation. What do these cells do? They promote cancer progression by energy, apoptosis, and cell cycle arrest of the T cells. Energy means basically non-recognition and non-reaction to any kind of immune assault. So they found that any of the tumors which are having a higher Treg population has a poor prognosis, poor survival of the patient, and ends up having recurrent tumors. So now you can see that slowly there's an emergence of two distinct populations of cells, immune cells. One is completely anti-tumor. Okay, so they remain faithful to the human or the host, and there is a subset of pro-tumorigenic immune cells who help in the proliferation and the growth of the tumor. So here what has happened, there is a shift between the good cells and the bad cells, and now we have a much larger enemy to deal with. So here comes the concept of hot and cold tumors. So when you have, what do you mean by hot tumors and what do you mean by cold tumors? So going by the same ideology of the previous slide, hot tumors are those cells which have proliferation and they have the infiltration of most of the anti-tumor cells, and cold tumors are those who are immunoresistant. So that means they have infiltration of those cells or increased number of immune cells who are pro-tumor, like tumor-associated macrophages and MDSC, myeloid-derived suppressor cells. So they have a higher population of these cells, which make the tumor immunoresistant. So now we saw that there was a multitude of mechanisms which are responsible for immune evasion by the tumor cells. Okay, I'd like to show you that these cells, the T cells and the T regulatory cells, they produce something called as immune checkpoints. Okay, and all the tumor cells, they have receptors to these immune checkpoints. So what happens even when an activated T cell is trying to fight the cancer cell, then what it does is it gives a sustained expression of these immune checkpoint receptors, and which induces the exhaustion of the T cell. So the whole the cells which were proliferated in a large numbers are now exhausted. So now there is only depletion and no repletion of these cells. So there are no more cells which are proliferating. The tumor cell has made sure that there is depression of the immune response and there is no proliferative activity. So the interesting thing here is, for therapy targeting such immune checkpoint receptors can have a reversal in the kind of immune response which is till now been suppressed. So let's move on to some of the immune checkpoint receptors which are produced by these cells. So what do they do? How do they cause immune suppression? So PD-1, which is secreted by the tumor cells, expressed by the tumor cells, what does it do? It dampens the tissue inflammatory responses by binding the PD-L1 to PD-1. I'm sorry, PD-1 is expressed on the T cells. Next, I'm just telling about few of these. There are so many more molecules, and if I start doing that, then we'll sit here whole day. So other molecules like CTLA, which is expressed on a Treg. Okay, so it's a competitive antagonist to CD27 and B7. So it will go and sit where the co-stimulator molecules have to go and bind. So, and finally regulates T cell activation. It doesn't allow the T cell to activate. There are other things like TIGIT and LAG3. What do? They inhibit T cell proliferation and cytokine production, which further causes immunosuppression. So to counteract all these mechanisms which are already in play, the latest, one of the most recent therapies in the field of cancer therapy is immunotherapy. So immunotherapy is one of the most recent methodologies, wherein even as recent as 2018 was when it won the Nobel Prize for Medicine. So here what is happening? It works on the premise that the cancer cells can be termed as foreign instead of self, and our immune system can be primed and can be stimulated to fight these cancer cells and eliminate them. So basically, it is stimulation of active post-response immune responses to the tumors, wherein the objective is to shift the state of the tumor from being an immunoresistant one to an immunosensitive tumor. So this can be done by using vaccines, by augmenting the host immunity to tumors with cytokines and co-stimulators. Basically, a non-specific stimulation of the immune system per se, and also restoring antigenicity as well as immunogenicity. So the different types of immunotherapy include active immunotherapy, target immunotherapy, adoptive immunotherapy, cytokine therapy, and also gene therapy. So it has been found that, when the researchers, two of the scientists who won the Nobel Prize, they said that probably it might take a decade to put this therapy into place so that each patient can benefit from this kind of immune therapy. But you see, it's just 2022, and already immunotherapy is a known and become an established modality. But they have found that it doesn't function very well on its own. So therefore, you have to combine it with standard therapies like chemotherapy and radiotherapy to achieve the best benefit. Also, there are a plethora of factors and targets which have been identified, which can be given through immunotherapy, through using different kind of vehicles and different mechanisms of introducing these molecules into our body, which will prime and which will activate the dormant immune system. So moving on to active immunity or active immunotherapy, these comprise of the anti-tumor vaccines. So these anti-tumor vaccines are basically therapeutic vaccines, right? So what do? Once they are injected into the body, they stimulate the immune cells, and they induce a higher activity of the T cells, and also the associated immune cells. So what do? So here there is a sustained killing of the immune cells selectively, and also there is a population wherein longer memory is provided against these cancer antigens which are introduced by these immunotherapeutic agents. So there are different types of vaccines: peptide vaccines, DNA vaccines, virus modified vaccines, and a combination of all these different vaccines. So right now, present research says that the best type of vaccines are the peptide bound vaccines. Okay. So there are so many trials which are being run on these vaccines, and even in head and neck squamous cell carcinoma. The second is target immunotherapy. So target immunotherapy, what it basically concentrates on is blockade of checkpoint receptors. Just like when the T cell exhibits PD-1 and cancer cell, it exhibits PD-L1. So when there is an interaction between these two, it causes immunosuppression. It causes deactivation of the tumor, the T cell. But when these get blocked by some other kind of antigen or antibody, then the T cells are able to proliferate and launch an immune response against this cancer cells. Similarly, it is able to do the same kind of reaction when you have anti-CTLA molecules, anti-TIM3, anti-LAG3, anti-TIGA3. So all these are identified as good targets for production of these immune checkpoint inhibitors. So drugs like nivolumab and ipilimumab. So these are drugs which have been marketed as those which are able to act as immune checkpoint inhibitors. Now moving on to monoclonal antibodies. So these monoclonal antibodies, you have multitude of target which are to be targeted, like in targetoid therapy. So this, when it comes to monoclonal antibodies, the specificity of their function becomes very precise. So you can make a antibody, you can structure it to any of the different targets that you can have in mind. So this has a lot of promise, and there are so many, not enough to know space to list the number of monoclonal antibodies which have been directed against these tumor specific and tumor associated antigens. Now the latest fad in immunotherapy is called as adoptive immunotherapy. So here what happens is that the blood of a patient is collected. In that we isolate the T cells and allow them to grow in an environment outside the body, reprogram these cells, and once they multiply, you send it back into the patient. So here these have the production, they have a chimeric antigen receptor called as CAR. So these CARs are ones who can recognize the tumor specific antigens very, very quickly. So there is a multiple fold attack back on the cancer cells once the patient receives this CAR T cell therapy. So this is the latest therapy which is being used as we speak. Okay. So next is cytokine therapy. So here in the cytokines therapy, they can be administered, those cytokines which will act on the tumor cells directly, they can be administered into the patient. And of these two, like IL-2 works by stimulating the proliferation and the anti-tumor activity of the natural killer cells and the T cytotoxic cells. And the second one is interferon gamma. What does it do? It increases again the cytolytic activity of the natural killer cells and class 1 expression class 1 MHC expression on all the different cells. So by doing this, it is enhancing the tumor response, which is still now being suppressed by the cancer cells. So there are different ways and means of activating this dormant immune response. Also, the dendritic cells can be primed to activate the T cells. So till now they were dysfunctional cells. Now you take out some of the dendritic cells, do some gene therapy, so remove and add some of the genes which will help to activate these T cells, and therefore it can activate the cells and also induce proliferation of the T cells, which again can launch an attack back on the cancer cells. So you can use viral vectors, you can inject it into these dendritic cells to help in this process. Now, what is this oncolytic immunotherapy? So this is now the most researched topic, that is wherein you have heat activated or live viruses, which are again programmed and allowed in along with the immunotherapeutic drug into the body. What does it do? It goes and selectively attaches itself to the different targets which are given in this slide, and it proliferates within those particular cells. So for example, you want it to target tumor cells. So you want it to target abnormal vasculature. You want it to target tumor associated macrophages. So each one of those can be specifically targeted, and the virus can enter any of these cells, proliferate and cause lysis of these cells. So it becomes a very highly specific and selective medium of targeting the cells, the cancer cells per se, and also their supporting cells in the tumor microenvironment. So this becomes a very ideal method of immunotherapy. So to conclude, I would like to say that though this therapeutic immunoediting, immunotherapy all sounds very ideal, it is not in reality. Okay, so all the patients are not responding to this therapy. Only about 25 to 40% of the patients respond to this therapy. So that can be attributed to tumor heterogeneity, the patient host immune response as well. It can be attributed to. So this needs a lot more work so that these treatments become more accepted by higher number of patients. So immunotherapy, it has its advantages, but it also has disadvantages. It has a lot of side effects like endocrine dysfunction, hormone imbalances. It can also cause in some patients liver and kidney toxicity. Okay, so we need to keep all these in mind, and as a doctor, we have to be empathetic to the patient. So here, early identification as always is the key, because they have found ways and means to not wait for the cancer to proliferate. It can also identify targets for those who are just transform cells, which have not become cancer per se. Okay, so PMDs can also be targeted by immunotherapy is what they are saying. So therefore, all of you, students, interns, general dental practitioners, they play a very important role, because you can identify the earliest mucosal changes when you look into a patient. So finally, what is the future, right? Future of immunotherapy, future of immunoediting is that each patient should be profiled immunologically and also undergo a molecular profiling, along with, of course, histopathology being the gold standard. okay, and developing and adopting a new classification of tumors based on antigenicity and immunogenicity will then direct precise and personalized treatment of each patient. So with that, I'd like to end my talk. I hope I was lucid enough. Thank you.
Thank you, ma'am. This was indeed a wonderful presentation. All the beautiful memories were down the lane after hearing you after such a long time, ma'am, of my PG days. Ma'am, there are few questions.
Yes.
Ma'am, there are few questions from the participants, ma'am. Can we take it?
Sure, sure.
Does regulatory T cells protect cancer cells, ma'am?
No, T regulator cells are working. Actually, they are produced whenever there is a autoimmune kind of scenario in our body. So they are also extended to, they are anti-tumor. I'm sorry, they become pro-tumor. That is, whenever a subset of T regulatory cells are produced, they end up in suppressing the immune activity of the other immune cells against the cancer cells. So they are actually pro-tumorigenic and anti-immunogenic cells.
Thank you, ma'am. Another question for you, ma'am. Are there any immune-related prognostic marker available? If they, what are they, ma'am?
Sorry, can you repeat that?
Are there any immune-related prognostic markers available?
Yeah, so right now the latest markers that we are looking at is the PD-1 and the PD-L1 markers. So, and also we look for FOXP3 positivity also. So all these markers, if we have found that to be increased in our cells using immunohistochemistry, using genetic markers, using any kind of tests that we can do nowadays, if we find an increase in these kind of markers, that means that the immunogenicity is being suppressed in these tumors. So if...
Yeah. Please, ma'am, continue. No problem.
No, so now we are looking at CD4, CD3 and CD8 ratios. Okay, so of course, if CD8 cells are more in number, that's the best scenario. But if CD4 and CD3 are increased, then it doesn't look so good for the tumor, for the patient, basically.
Thank you so much, ma'am. Now it's our great pleasure to hand over you a certificate of appreciation on behalf of Vishnu Dental College, ma'am.
I would really want to take this opportunity to thank the Department of Oral Pathology at Vishnu Dental College, their principal, the management for giving me this opportunity. And also I would love to thank Shweta and Smita. These guys I've known them for more than a decade now. And also Yoitab for taking us down memory lane and showing us such wonderful pictures and, reminiscing about our PG days. So thank you, and thank you for listening patiently to my talk. Thank you very much.
Thank you so much for accepting our invite also, ma'am.
Thank you. It's a great pleasure, actually.
Now I will hand over this forum to Dr. Satya Tejashvi. She will continue the program.
Thank you, ma'am. It's a wonderful presentation. We have conducted 2 more events in addition to these lectures in the name of fact. Those are Rangoli, I design better than I talk, and 1 minute talk, carve every word before you let it fall, with theme related to concept of oral pathology. We congratulate and appreciate all the participants who have been participated enthusiastically and passionately in these events. Here are some of the best pictures of Rangoli we received.
షేర్ లోపల వచ్చిందా రైట్ ఇప్పుడు కనిపిస్తుంది అది రైట్ ప్లే
The first prize goes to Dr. Himanshu D. Dhanodkar and team. From Sri Aurobindo College of Dentistry, Indore.
మా ప్రైజెస్ వచ్చినప్పుడు జియో ట్యాగ్ పెట్టి ఫొటోస్ కి అని
The first prize goes to Dr. Himanshu D. Dhanodkar and team from Sri Aurobindo College of Dentistry, Indore. And the second prize goes to R. Kirtana, Kammana Nitisha, Ravichandana from Vishnu Dental College, Bhimvaram. The third prize goes to Dr. Renuga S., Dr. Hazira Kaloon, Dr. Akalya P. from Government Dental College and Research Institute, Bangalore. Here are few videos of 1-minute talk on the concept of oral pathology as a special entry. బయట ఉంది.
Hi, myself Dr. Pinky Pavitran, Being a proud oral pathology student, it is indeed a great privilege for me to speak about oral pathology being a special entity. Like any other pathology group like nephropathology, neuropathology, pediatric pathology, hematopathology, or our oral pathology do play a crucial role. I would like to call ourselves diagnostic detectives of oral and maxillofacial region because with our visual power, with our observation, with our thinking and reasoning, we are able to solve the mystery in the oral and maxillofacial region. So I would like to call it as an art form, and we should be really proud about it. And also, being a professional dental surgeon or a qualified dental surgeon, we do have a slight edge because we know what is abnormal from normal, and so we can improve the overall life of a human being. And definitely we should have passion for this, because one day this passion will become our purpose and we can save different lives. And if we don't do our part, who else will do it? Thank you.
Oral pathology is a specialty of dentistry that deals with the nature, identification and management of the diseases of the oral and maxillofacial cavity. Oral pathology is critical in dental care as it helps in diagnosing the oral diseases and in solving the problems in faster manner. Oral pathology deals with the common diseases like leukemia, polycystic granules, cancer of the oral cavity. Oral pathology also deals with the oral manifestation of systemic diseases like bone, including diseases of bone, blood, and skin. Oral pathology also deals with the salivary gland pathology. Oral pathology mainly deals with the histological features of the diseases. Oral pathology also includes developmental anomalies, cysts and tumors, injuries, and syndromes of the oral cavity. It also deals with the metabolic disturbances of the oral cavity.
Hello friends, this is Likita of 2nd VDS from Vishnu Dental College. Today I am here to speak a few words about oral maxillofacial pathology. It is a part of dentistry. It is a science of dentistry which deals with the pathogenic diseases and disorders in the oral cavity. The main aim of oral pathology is to find out the diseases of oral cavity, whether it is a cancerous or lesion or benign tumor, etc. So oral pathology plays an important role in every dentistry department. It is nowadays going over the research side also to find out new pathogenic conditions like mucus fungi. So these were few lines about oral maxillofacial pathology which I wanted to speak. Thank you for giving this opportunity.
We celebrate Feb 25th as the National Oral Pathologist Day. This day was initiated by the Indian Association of Oral and Maxillofacial Pathologists to honor Dr. Harinath Manishankar sir by dedicating his birthday. Oral pathology allows us to diagnose the symptoms and deliver the proper treatment quickly where there is a problem. Oral pathology as a super specialty seldom make as a cut as a preferred choice of post-graduation and career due to several challenges being faced due to present scenario. Oral cancer is the most common cancer and accounts for the 30% of all malignancies in India. Furthermore, 7.8% of the global cancer burden is contributed by the India. The fast increasing rates of oral cancer and manifestations of other systemic diseases to oral and maxillofacial regions require and will be definitely benefited from the nurturing of the field of the oral pathology. Therefore, by becoming competent in the subject, making necessary changes to the oral pathology curriculum and incorporating proposed solutions, the grace of the oral pathology can be maintained as well as grooming. Thank you for giving this opportunity.
Once again, thank you for all the participants, and the first prize goes to Dr. Pinky Pavitran from Malabar Dental College, Kerala. And the second prize goes to Dr. Katta Ramakrishna from Vishnu Dental College, Bhimavaram. We again congratulate and appreciate all the participants. Dear participants, feedback form was posted in the chat box. Kindly fill it and submit it as the earliest, and you will receive the certificate within 2 days. As the event has come to end, I request Dr. Sweta, Professor from the Department of Oral and Maxillofacial Pathology, Vishnu Dental College, to deliver vote of thanks. And thank you one and all for giving me this opportunity. Thank you.
A very good morning, one and all. It's an honor to have asked to say vote of thanks on the successful completion of our CDE program, FACT, Fundamental Analysis of Cancer Treatment, organized by the Department of Oral and Maxillofacial Pathology on the occasion of Oral Pathology Celebrations, Vishnu Dental College. On behalf of entire management, Vishnu Dental College, I heartfully thank all the participants for attending FACT. We have been fortunate to have been renowned identity in the entire Andhra Pradesh. I am very thankful to our chairman, Sri K.V. Vishnu Raju Garu, vice chairman, Mr. Ravichandran Garu, and our director, Dr. M.A. K.V. Raju Garu, who have been constantly supporting us to conduct such wonderful programs. I also thank our principal, Dr. Suresh Sajjan sir, and our vice principal, Dr. A.V. Ramaraju sir, for their leading supervision and inspiration at every point of time. And I also thank all the heads of the departments for supporting us. I would like to extend my sincere gratitude to our guest speakers, Dr. Soumya Makarla and Dr. Yoita Prabhunathan, my beloved friends, for accepting our invitation within a short duration of time and sharing their valuable knowledge. Thank you so much. Last but not the least, I show appreciation to my HOD, Dr. Ravikant Manyam, and my dear colleagues and the most energetic postgraduates who have been the strength for this successful event. I also thank Mr. Surya, Mr. Bharat, technical team for their support and help. Once again, I would like to state that we are all glad to the guest speakers, Dr. Soumya and Dr. Yoita. Have a great day. Thank you once again.